Okay, we have this equation, that's the reduction potential. So this is the reaction or the half cell equation, and then this is the reduction potential. Reduction potentials are also the same as what? Electrode potentials. They are showing the tendency of what? Of an electrode to gain electrons. Are we together? Yes. Because last time we said reduction is the same as rig, whereby reduction is gain of electrons. So all these are a measure of tendency of an electrode to do what? To gain electrons. Are we together? Yes. Now we move to the first question. State whether acidified manganate 7 can be oxidized. Give a reason for your answer. I think can oxidize. M2 positive. Can oxidize. And then give a reason for your answer. Now let's see. So what you need to do is you put MnO4 on the what? On the left hand side. Are we together? And then M2 positive on the what? Right hand side. In other words, MnO4, in other words, we do it like this. MnO4, okay? And then we have what? Plus what? M2 positive. This one to lose electrons and this one to gain electrons. So this one to be on the left hand side and this one to be on the right hand side. This one to undergo what? Oxidation, and this one to undergo what? Reduction. So what do? You calculate the EMF of the cell. What is EMF? You say EMF is equals to E standard right hand side, that is reduction. You can just say EMF is equals to E standard redox, reduction followed by oxidation, less E standard left hand side, which is going to be, what is the EMF of M2, standard electrode potential of M2 positive? Positive 0.77. Are we together? So here we have, positive 0.77 we less manganate. Standard electrode potential, positive 1.44. So you less positive 1.44. Use your calculator. What do you get? Negative 0.67 volts. Now let's go back to the question. State whether acidified manganate 7 can oxidize M2 positive. Give a reason for your answer. Can it oxidize? No. Look at this. You look at the value. Is it positive or negative? Negative. So you say no. Okay, you put a comma. And then you explain. What's the explanation? You say EMF of the cell is negative. Okay?
Yes.
So you say no, the reason is EMF of the cell is negative. Okay? Therefore, reaction does not occur. Or you can say reaction does not occur. Reaction doesn't occur. Okay, reaction doesn't occur, and we have seen the reason why the reaction does not occur. Because the EMF value is negative. Electron. Okay? Is that the value of what? P. Of what? Of A. Of A value of the half cell of A, if P was used as reference electron. Show you are working. Are we together? So when you are doing this, whichever cell you are dealing with, whichever electrode you are dealing with, then it is usually that electrode less that of hydrogen, which is usually the reference electron. So in this case, it will be the electrode potential of A will less that of P, because P is the reference electron. So you do this, you say EMF is equals to E standard of the cell of the electrode that you are dealing with, which is of A, will less E standard of the reference electrode, which is now P, which is going to be what? A is reference reduction potential of A is positive 0.34. So it will be what? 0.34 will less the reference electrode, which is P. What is P? Negative 0.23. So less negative 0.23. Are we together? Now what do you have? 0.34 minus negative 0.23. What do you get? So you get positive 0.57 volts. Are we together? I hope you have noted. To get the reduction potential of any electron, what do you do? It is reduction potential of that electron with less reduction potential of the reference electron. Are we together? Yes. Now, the next question is this. Select two half cells which would produce the highest EMF when combined. Select one back and come here. Half cells which would produce the highest EMF when combined. From left to right. Are we together? So which will be on the far left? This one which is having a negative. Negative 0.23. So we start here from negative 0.23 volts. We move to the next. After negative 0.23, we go to positive 0.34. Okay? So here we have positive 0.34 volts. From positive 0.34, we move to positive 0.77. So this is positive 0.77 volts. And then from positive 0.77, we move to positive 1.44. So here we have positive 1.44 volts. And then lastly, we have positive 2.86. Positive 2.86. Okay, volts. Now, when you are told to identify the cell that will produce the highest EMF, then you look for the one which is on the far right, and then the one which is on the far left, on the number line. Are we together? Far right, positive 0.2, positive 2.86. Far left, negative 0.23 volts. But remember, you have been told to select two half cells. So which one is having negative 0.23? Which half cell is negative 0.23? It is a cell of P. Okay? But P is not an half cell. P is an electron. Are we together? So you write the whole of this equation. That is the half cell. Are we together? So you'd say P, 2 positive plus 2 electrons, okay, to form P. This was, that is P. And then, which one is below, is positive 2.86? Yes?
T.
T. Is it T?
Yes.
Very good. So you write the equation for T, which is T2, okay, plus 2 electrons, like that. You write 2T. 2T ion, like that. And that is how to respond. So actually, the EMF is the space in between. There's a big space between here and here. You see? So this EMF is very big. You see? But you can be asked another very simple question. Identify two half cells that can produce the smallest EMF. Okay, let me write that one here. Identify two half cells that will produce the lowest EMF. Now for this one, you don't look for the one which is on the far right and the one which is on the far left. You are going to carry out calculation. You look for the difference between this and this, this and this, this and this, and this and this. In other words, you look for the difference for those two which are close together. And you will carry out, and you subtract 0.34 and 0.23. And you subtract 0.34 minus negative 0.23. What do you get? 0.
Positive.
So here we have positive 0.57 volts. This one 0.77 minus 0.34. 0.43. Very good. So here we have 0.43 volts. Okay. 1.44 minus 0.77. Yes, this is positive. Very good. 1.44 minus 0.77. Positive 0.67. Positive 0.67 volts. And then lastly 2.86 minus 1.44. 1.42. Positive 1.42. Very good. Now, a very simple question. Which one has produced the lowest EMF? Which is the lowest EMF?
0.43.
So we have positive 0.43 as the lowest EMF. That is between which cell and which cell? Yeah, 0.77 and 0.34. 0.77 is which one? M. So you write the whole equation for M. So you say M3 positive plus electron. Okay, this is aqueous. What do you form? M2 positive aqueous. And which one? This one and this one. Which one belongs to 0.34 is for A. So the other side half cell is A2 positive aqueous plus what? 2 electrons. Okay, what do you form? A, which is a solid. Like that. So those are the two half cells. I hope you have noted the difference. Highest EMF is the one which is on the far right minus the one which is on the far left. The one which is having the biggest space. Are we together? Lowest EMF is actually between two half cells which are close together. So you now test each one of them until you get the one which has the lowest EMF. And when you are told about the half cell, make sure you write the whole equation the way it is. Unless you have been told electron. If it is electron, you write only one symbol. If it is M2 positive alone. If it is A, you write A alone. If it is electron. But half cell, you write everything. Are we together? Good. Lastly, a question. You are being asked to predict whether a reaction is going to take place if you put a solution of A in a container of B. In other words, whether P is going to undergo what? Oxidation and A to undergo reduction. So EMF, as we have just written here, is equal to E standard reduction less E standard oxidation. Now, EMF, how are we going to calculate the EMF? If EMF is equal to E standard right hand side will less E standard left hand side. Now right hand side we have A. So this one is the E standard of A. Then left hand side is the E standard of P. Okay? The standard reduction potential of A is positive 0.34. So here we have positive 0.34. We less the standard reduction potential of B, which is negative 0.23. So we less negative 0.23. Can you use your calculator and give me the answer? It is
0.57.
positive
0.57.
positive 0.57 volts. Now, having got this 0.57 volts, can you place the solution in that container? We cannot place it. Are we together?
Yeah.
Because when the E standard value or the EMF value is positive, it means the reaction will occur. In other words, corrosion will occur. So we write that one, we say our response is no. Okay? Why no? You say what? EMF for the cell is positive. Therefore, corrosion is the same as what? Reaction will occur. Producing negative 0.23 volts are combined, it will produce the highest EMF. So what you do, you will just take a container like this representing a bottle. This bottle, it is, which one are written 2.86 belongs to iodine. Okay. T, this is T. Is this a solid or a gas? A gas. This is a little bit tricky.